Hello everyone. So next unit is central processing unit. So in this we will see the working of CPU and which are the main components in CPU and how they are working. So it is a part of computer that performs the bulk of data processing operation. So you can say it's a heart of your computer system, right? So means it perform all the operations arithmetic, logical, right? That is performed by CPU, and there is a part of CPU which performs this operation. So it made up of three major components. So these are control unit, your register set, and ALU. As I said, ALU, right? Arithmetic and logical unit. So this will perform arithmetic and logical task, right? So operation that is performed by ALU. So while performing such operation, right, you require data and you need to store those data. So this register set, right, that is useful in that. Okay, and this control unit which control this means from which register they will get data, right, and to where or which is the destination register. So this is handled by control unit. So control unit instruct your register set and ALU means which operation need to perform, that is handled by this control unit. Okay, and the data that is transferred from register to ALU and then from ALU to register set. So these are the three major components of your CPU: ALU, register set, and control unit. Now register set. So what is the use of this? So it stores the intermediate data used during the execution of the instruction. When your ALU performing some operation, it requires data. Now, if ALU wants that data and that data is in memory, right? So to get data from your main memory, it will take a lot of time. So rather than that, the data that will be stored in your registers. So to access the register is faster compared to your main memory. So you will get data at the speed of your CPU. Now, when you perform some operation or your ALU perform some operation, right? At that time, sometimes you require to store intermediate data. So at that time, you also require some storage. So that is provided with this register set, right? Then your ALU, it performs the required micro operation for executing the instruction. Like you have add instruction, so it perform addition. You have sub instruction, so it will perform subtraction. So that thing and or operation. So that is done with help of ALU. Then your control unit. As I said, it supervises the transfer of information among the registers and instruct the ALU which operation to perform. Right. So that instruction, which operation to be performed, how data transfer took place, that is handled by control unit. Let's see the structure and behavior. So as seen by the programmer, which uses the machine language instruction, we are using high level language like C, Java and all, but the language instruction, right? So they must be aware about the instruction formats. Right? We'll study this instruction format addressing more than your instruction set in this unit. So that machine language programmer must know the instruction format. What is the instruction format? What is the addressing mode? Right? Sometime in your instruction, the value is directly given, and sometimes you need to refer to that memory. So such cases or such thing must be known by that programmer. And the general organization of the CPU register means how many registers are there and how to select those register. So that must be known by the programmer of machine language instruction. So the user who programs in machine or assembly language must be aware of the register set, the memory structure, the type of data supported by the instruction, and the function that each instruction perform. Right. So at the low level, the whatever thing you have, that must be known by your machine level programmer, right? Because whenever he writes instruction, that person must know about your register set, how many registers are there, how you can select those register, what is the memory structure, and as he's going to implement your stack, right? So he must be aware about the memory structure and which part of the memory is available for stack. Okay, so this all the things, type of data and function must be known by your programmer of assembly language. Now let's see the general register organization. So why register? As I said, the memory access time is large. So whenever you access data from memory, so operation will be performed by ALU. Now to perform operation on data, you require access from memory, and suppose you are accessing from your main memory, then it will take long time. So your CPU, okay, and specific component, that is ALU, will wait for data, right? So your ALU can perform task very fast, but as ALU does not have the data, so that ALU needs to wait, right? So rather than keeping or getting the data from main memory, the data will be stored in register, okay, or brought into registers. And then whenever ALU requires data, it will access register. Registers is used to store pointers, your counters, your return address, temporary result, and partial product during multiplication. So if just assume this all thing, right, which is you might be encountered during your program, and for each thing, if your CPU will go for memory access, then it will consume time lot of time, right? So instead of that, keep this thing in registers. It will be very fast to access this data, right? Or suppose you have suppose 4 to 5 functions and you are calling those functions. So each time you return to your main, and every time you are accessing your main memory, then it will take a lot of time. Okay, register stores such kind of data. Even when you're performing multiplication for each partial product, suppose you are storing it into main memory, then every time CPU need to access your main memory. So large number of registers in CPU, and they are connected to a common bus system. This is the block diagram of it. The register connected to ALU with the common bus. So right now this is a 7 set registers, right? So 7 registers are there, and they are connected to common bus. So you can see the registers output is connected to this mux and this mux as well. So there are two bus to ALU, A bus and B bus. So means what? ALU get two data, and on that it will perform some operation. On this it will perform some operation. Now there will be only one data, right? So with the help of multiplexer, out of this 7 register and input, there are three selection line. Means this is 8 by 1 multiplexer, right? 8 inputs, 1 output. So 7 registers and 1 input. This is the external input, right? If you are taking data from external device, then you need to choose this one. So all will go to multiplexer. Just name this A in this multiplexer. Okay, and this selection line will select which value it will allow to pass, right? So suppose I want to allow R2, right? All are connected. You can see R1, R2, R3, R4, R5, R6, R7, and your input. So 8, I want to allow only one to pass in this A bus. So suppose my data is R1 and I want to allow this thing. So my selection line that must be 0, 0, 1. So in that case, whatever the value R1 has, that will be passed to this, and ultimately it will go here in A bus, right? Same thing for this mux. So B bus, we want data. Again, all registers are connected here, and your input. Now to select the second operand, you can use this one, this selection line. And suppose now at this time your data is in R5 and you want that whatever value you have here, that must be passed to bus B. In that case, your cell B selection for this B, that must be 1, 0, 1, means 5. In that case, that will be passed to B bus, right? So now you have two operand A and B through bus A and through bus B. Now your ALU, arithmetic and logic unit, you have data. Now you need to perform operation, arithmetic or logic. So ALU, ALU, based on this operation, there are 5 lines. Okay, there are 5 lines. So arithmetic operation, logical operation, that can be performed through this ALU, arithmetic and logic unit. So this operation will it will select which operation to be performed: addition, subtraction, transfer, which operation, or operation, and operation. So that will be select by this operation. Okay, so we have data, operation is selected, and then this ALU will perform some operation. Okay, and then it will give the output. Suppose you want to select this one input here. So in that case, your selection must be 0, 0, 0. Now this operation, this is your S3, S2, S1, S0, and this is carry in. So while you are performing arithmetic operation, you require this carry in. But for logical operation, there is no use of carry in. Now there are 4 selection line: S3, S2, S1, S0, right? We have seen in practical that there are 3 selection line: S2, S1, S0. Now there is one more. So why that? So some arithmetic operation will also allow to perform shift operation, shift right or shift left, before operation or after operation, right? So in such case your S3 is required. So now S3 and S2, this is used to perform or used to select between arithmetic, logic, shift left or shift right. So 0, 0, 0, 1, 1, 0, and 1, 1. So this is for shift, this is for arithmetic, and this is for logic, right? Now this operation, we will see the table, right, for like this 5 bits. And for addition, what should be this 5 bits binary values, that we'll see in some table later on. So the output, you can see the output of ALU, this is going uh, out, means some external device. and it's also going to registers in all the registers. You can see it is given to all the registers, and this is parallel load, means it is 8 bits, then all 8 bits are connected to this registers. Now whenever you enable particular registers, that data will be stored in that. Right now all registers receiving that data, but whichever register is enabled, that register will store the data. So for that we have decoder, right? So decoder will enable only one register, means it will select the destination register. So decoder will perform that task. So how many means possible destination we have? So 7 registers and one output, right? So if decoder value is 000, so in that case the no register will be enabled, right? In that case data will be passed to output. Then if your decoder, right, this is 3 by 8, means 3 selection line and 8 output 0 1 2 3 4 5 6 7. So whenever you select this line, it will pass 1 to that line. So suppose I want to store the result in R1. So as we have data here, means in all the registers and at output as well, right? So now I need to enable R1. Now to enable R1, that registers enable value must be 1. So this is connected to each enable line of each register. The output of decoder means let me write 0 1 2 3 up to 7. So 0, right? Output, no need to connect. This 1 will be connected here to enable R1. This 2, this will be connected here to enable R2. Now when you select 0 0 1, right, at that time R1 will be selected, means this is enabled now. So whatever the value you pass here, that will be loaded into R1. And in other means in other lines 2 3 4 up to 7 and 0, what you will get? You will get 0. The other register will not be enabled, right? So they will not store that data. Only R1 is enabled, so R1 will store the data. So this is how data transfer took place in your CPU, or common bus between register and your ALU. Okay, so now assume that we want to perform this task R2 plus R3 addition, and result must be stored into R1. So two operands R2 R3 addition operation, and result we want into R1. So how information flow? So control must provide binary selection to variables to the following selector inputs. So whenever you want to perform this operation, right, each control must be decided. Each control must be decided. So that is provided by your control unit. That is provided by your control unit. Now, first we want R2, right? R2 in A bus, this one, right? So to place content of R2 in bus A. So we want this in A, R2. Here, what we want? Here we want R3, right? So for that, you need selection B. For this, you require selection A. These 3 bits for this selection. Then ALU operation. ALU operation. So OPR. So this thing, OPR. This will select the operation, and we want addition. So we'll see what is the value for it. Then your decoder needs to select destination register. Select D. It will select the destination where you want to store the data. I want to store into R1. right? Okay. So these four control selection variables are generated in the control unit. Means what is the value of cell A, cell B, OPR and cell D that is generated in the control unit and must be available at the beginning of the clock cycle, right? Once it is in available, then this operation will be performed. Okay. So control word. So that four uh, selection that we have seen that forms a control word. So selection inputs in the unit, selection inputs. So cell A, cell B, cell D, and OPR that are the selection inputs. Their combined value specifies a control word. Uh, so we have seen this select A, right, to pass the value in bus A, select B to pass the value in bus B, to select the destination or to pass the value in destination and your OPR. This is 3 bits, 3 bits, 3 bits and 5 bits. 3 bits, 3 bits and 5 bits. So this forms 14 bits control word, right? So what cell A this will do? It select a source register for the A input. What B will do? It selects a source register for the B input. Select D, select the destination register using the decoder and its 7 load outputs, right? So this selection D that is given to decoder only. On 7 load outputs, it will um, just given as an input to register. Then your OPR select the one of the operation in the ALU. Let's see the encoding of register for selection fields. So this is the table and it's a very simple. We have 7 registers and one input. 7 registers and one input. So 1 to 7 bits are there. So you can go to 000 this thing to 111, right? So 001 R1, R2, R3, R4, R5, R6, R7, and for 000, if it goes to input, then it will select the external input. And when 000 in select D, then it will not store into destination register because it will directly given to external output, right? So if you want to get data from R3 as a one operand in A bus, then the selection of A bus must be 011. And select B. Suppose you want second operand from R4, then this must be 100. And the result you want to store into R6, then the select D must be 110. Okay. So this is the selection field for cell A, cell B, and cell D. So from control word, right? Cell A, cell B, cell D. Now we know how to put this value. Now OPR is remaining. Now encoding of ALU operation. So 5 bits, as I said, this is S3, S2, S1, S0, and C in carry in. So S3, S2, 00, 01, 10, and 11. So see 00 up to here, then 01 here, and 1011. So 1011 it performs what? Shift operation. But 10 is shift right and 11 is shift left. So this is shift right and this is shift left. 01, 01. So you know that we were using S2 to select between arithmetic and logic. If S2 is 0, then it's a arithmetic. If it is 1, then logic, right? And there is no use of C in except this arithmetic operation. So when you write 00000, 5 bits, right? So using this, it's arithmetic operation. It's arithmetic operation. Now these 3 bits, just remember the thing that we have discussed in practical of ALU, right? Using this, you get to know that as 0 is 0, S1 is 0, and C in. So what it does, it just transfer the data, transfer A, and symbolically it can be represented like this: TSF A, right? TSF transfer A. And like take another one, addition. So 00010, this is addition, and this is the symbol of it. So to perform addition on two operands, you need to pass 00010 to OPR. Okay, so for other things we have this OPR selection. This is for logical operation. This is for arithmetic operation, and there are others as well. Let's take the example. So R1, this is the destination register, which are the operands on which we are going to perform the operation, that are R2 and R3, on which we are performing subtraction. So as you know, this is the control word. We need to specify this control word, right? Once we give the control word to CPU, then it will perform this operation, R1, R2 minus R3, right? And control unit will generate this control word, and it will pass to CPU, and based on that this operation will be performed, right? So these are the field. Now what you require in cell A, so symbolically if we see, then cell A means this thing, this selection. So in that R2 must be selected. For this second operand R3 must be selected. What is the destination? It is R1, so R1 must be selected. And operation, what is the operation you want to perform? Okay, so for R3 R2, what with the 3 bits? 0 1 0. For R3, 0 1 1. For R1, 0 0 1. And subtraction, so for subtraction, this is the code 0 0 1 0 1. 0 0 1 0 1. Let's see the previous table. So subtraction, 0 0 1 0 1, right? So now this is your control word. This 14 bits will be passed to your CPU, and then CPU will perform this operation, right? Okay. Take another example. So R4 is the destination, R4 or R5, R4 or R5, right? So control word, 3 bits R4, next 3 bits for R5, destination result must be stored in R5, yes, and OR operation. So for OR, it's a 0 1 0 1 0. You can see it's a logical operation. So this is 1 now, right? If it is 0, then it must be arithmetic. Okay, now it's 1. Okay, then output R2, whatever the value we have in R2, directly I want to pass to output. Directly I want to pass to our output. So in that case, here 0 1 0 is R2, R2, right? Select B. So you can select just input, okay, or it will not do anything. So 0 0 0, you can put anything in this. Then your destination, you are going or you are giving the result to output. Your decoder value, your destination must be 000, and there is no operation, not no operation, transfer operation, you can say. Transfer a, whatever value you have, that you are going to transfer, so transfer a. So the operation for that is 00000. This is arithmetic, you can see it is 0. So this is arithmetic. Okay, like another example, I want to reset register 5. I want to reset register 5. So what to do? So just see this thing. When you perform XOR with that value, suppose A XOR A, it will give you 0. When you perform XOR with this, it will give you 0. So that thing will keep in mind and will write the control word. So for it, what we want to do? R5 XOR R5, and this result must be stored into R5, right? So select A, R5, select B, also R5, and result also we want to store into R5. Result we want to store into R5. Okay. Now what we want to perform? We want to perform XOR between A and B. So this is OPR for XOR. That is 0 1 1 0 0. You can see 1 means logical operation. So let's verify OR. So where is OR? This thing. So 0 1 0 1 0. So yes, it is OR. Then transfer A. Whatever we have, we are going to transfer to output. So 0 0 0 0 we were specifying. Yes, transfer A. Then your reset means how to reset it using this operation. A XOR A means R5 XOR R5, it will reset. So for XOR, what is the operation code? This is the operation code 0 1 1 0 0, right? So this way you can write a control word, and that must be passed to CPU. So your control unit will generate this. Okay. Hmm. So control memory, a memory unit that stores the control words, that is called a control memory. Okay, because we have seen the control word for example. Suppose this for example we want to perform one by one, right? So one by one I need to give this control word to CPU, and once CPU get that, it will perform the operation one by one, right? So that is called a micro program control, right? So what is this? By reading consecutive control words from memory, which control memory, it is possible to initiate the desired sequence of micro operation for the CPU. And this type of control is referred to as micro programmed control. So suppose first you want to perform this thing, and then you want to perform this thing, this operation you want to perform. So what you need to do? This control word that is stored in memory, that is called control memory, right? So this will be stored control word, then second this control word will be stored, and then this will be, you can see, so by reading consecutive control words, so one by one from control memory, the control word will be read, and using that it will initiate the desired sequence of micro operation or the CPU. So we have generated the desired operation. First we want to perform this OR operation, then we want to perform transfer operation. So this can be done, and this is referred to as micro program control. Micro program control, right? So thank you. This is it for this lecture.